time. Investigation 6.1, the launch angle and range. Do not be intimidated by this lab. Yes, marbles will go flying. That is perfectly okay. Now, this lab 6.1, since it is the introduction of this new equipment, it does give some very detailed instructions for students about how to set it up to make sure that they get accurate results. I'm going to be showing it up here, but of course, students, when they do the launches, are going to have to be down on the floor, and these need to be stationary down there. So, keep that in mind with how your classroom can be set up, or do we need to move into the hallway? You should have at least 2 people per marble launcher. You can't do this experiment on your own. Groups of 3 or 4 should probably be fine, but you'll need somebody down here making sure that they are launching from the exact same position. It recommends putting masking tape down to indicate where this should be. So make sure that one person is in charge of making sure that this hasn't moved throughout the experiment. And then they will be launching. You pull this down. It recommends, or at least it's written, that you set it to the 5th setting. Now, if you have a smaller room, before you make mass copies, change that instruction that's on page 2 to say 3rd setting or something like that. So, depending on what you have going on, you may want to change that. Now, the marbles that they're using are plastic, so these aren't the steel balls, so they're not going to make any damage, so we'll be good there. If you are on the ground and you have the typical tiled floors, you can double check the measurements, but those tend to be 1 foot. And so if you have your students start this at the start of one tile, then it makes it easy to measure out a distance, especially in feet. Now, this is probably going to want it in meters, so imagine a conversion, or just have some measuring tape for them to measure out, and probably some more masking tape, because the other person's going to have to keep an eye on where the ball is landing. They may want some markers. So masking tape will be super useful for this. The idea behind this project is that they're going to investigate the different launch angle and how it sends the projectile. I believe that they are going to start up at a high, so it says 85. This has an arrow pointing on it, so now you should see that I'm starting at, that's 75, that's 85. Okay, let's double check that that is indeed what I'm doing. Oh, we actually start at 10 and we go up to 85. Always read the instructions before you start, guys. Okay, so you can adjust the angle. If you leave this just slightly loose, it lets you move it without it falling, and then you hold it in place, tighten it up, and he's not going anywhere. So students are going to be testing different angles, starting at 10 degrees and going by 5s, 15, 20, 25, and so on until they get to 85 degrees. And then measuring the distance. What they should find is there's a sweet spot somewhere in the middle, and that's kind of the gist of this experiment. There's really not much to it. Make sure that they know that when they're launching, excuse me, that they're not interfering with how this guy gets launched. So if they're trying to push it down but the thumb's in front, they're going to mess up the launch. So typically I just kind of come from it slightly behind and knock it down, and off it goes flying. Now, just from that launch there, that was pretty intense. Maybe go with the 3rd notch for this experiment. That went really far. And I don't think you have the classroom size to do that. But totally up to you. Test it out for yourself first. They plot a graph on this next page to show exactly where that peak is. So they should see a nice little curve. And oh, they're at 45 degrees is our peak. And actually, yep, 45 is on there. So they will find the peak. This is what it looks like at the 3rd setting. Not as bad. It did hit the water fountain, so it sounded bad. So that is investigation 6.1. I'll see you guys for the next one.